In this session, I am going to explain about selection factors required for operating a drive. So, what are all the factors required before selecting a drive? So, there are several factors in which one of the few factors we are going to discuss are steady state requirement, transient response requirement, requirement related to availability of source, capital and running cost, maintenance need, space and weight restriction, environment and location, and finally reliability. So there are totally 8 factors, out of which steady state requirements, transient requirements, and then requirements related to source. These three are the most important factors that is to be considered for the operation of the load before selecting a drive. So, what are all the factors that a steady state requirement involves is it involves about speed versus torque characteristics of a motor and subjected to load, and then speed regulation, efficiency, range, speed range, duty cycle factor, suppose in case of a DC drive, and then operating quadrants, then finally fluctuations of speed. So these are all the internal factor that decides the steady state requirement of an electrical drive. Coming back to the transient response, as we discussed about the transient response in earlier lecture, transient response gives a clear picture about motor subjected to load during failure condition. It may be a failure condition or else any change of load, sudden change of load during the fraction of seconds. What happens or else what are the effects that a motor should withstand? So based on that, the drive system will withstand in the sense acceleration and deceleration concept, sudden rise in speed and then as well as fall in speed, braking and reversing action, and consumption of current during the starting. So these three are the very important internal factors that affects the transient response, and this transient response are always related to the output side. So the first two cases, steady state and transient response, are completely deals with motor connected to the load. Third factor is requirement related to the sources. This sources is completely, it depends on the input side. So it is electrical, it is going to be electrical steady. So what are all the internal factors that affects is what kind of source, whether it DC or AC, followed by magnitude or else voltage and current fluctuations subjected to any type of transient condition, and inducement of harmonics, that is unwanted signal noise when subjected to the transient state, and power factor are the few internal factors that affects which are very closely related to the source. Apart from that, the remaining factors such as running, maintenance, capital investment, followed by the compactability, whether it is bulkier or very simple in nature, then operating environment and pollution causing. So electrical drives are does not cause pollution to the environment, and the lifetime, overall lifetime, the reliability. These are all the general factors which are very closely related to the selection, and a consumer or an engineer in an industry should concern about all these factors for choosing drives. So once all these factors are considered, then we are going to discuss about the classification of electrical drives. So electrical drives can be classified as very three major categories. One is group drive, individual drive, and the multi-motor drive. And this chapter is a very quite simple topic. It is very simple that a group drive, when one motor operates a group of loads, it can be classified as group drive. That is, when there are n number of loads connected to a one motor. So in precise a single motor operating with n number of loads. Then generally it is used for larger power rating when a load consumes a larger amount of energy. Similarly, the motor should be able to have larger input on the input side. So the next one is the individual drive. When a single load is being operated with the help of a single motor, that is classified as an individual drive. And the next one is a multi-motor drive. So for operate a larger load, here when the load is of very high output power in terms of Newton meter, torque, and then as well as speed in terms of watts mechanical power, when it requires a larger power, suppose sometimes a single motor or 2 or 3 motors are not sufficient enough to operate that type of load, a multi-motor connected to a single load, that is categorized as a multi-motor drive. So in all these classification of drives, just we are going to control the parameters on the input side is voltage, current or flux, and then followed by frequency in case of an AC system. So all these three parameters, whether it is a group drive or an individual drive or a multi-motor drive, are able to control the output mechanical power. So this type of multi-motor drive systems are generally used for metal cutting, paper making, paper machines, and then in rolling machine, rolling the paper mills. It is generally preferred. So these are all the classification of electrical drives. To summarize with 2 chapters, one is the choice or selection of factors, and then classification. There are three basic classifications of electrical drive. Coming back to the selection of factors, it is very quite simple that it should respond three important things. One is steady state requirement, which are related to mechanical loads, then transient response, which are related to mechanical loads, and the third important thing is relation requirements related to the that is source on the input side. So the sources are completely dependent upon electrical and then as well as mechanical systems. Thank you.